We're fucking live again. I'm having curry tonight. I had a tarot reading with meme analysis. The actual meme analysis guy. He allows you to like schedule him for a tarot reading if you want. He told me that I have a roaring energy inside me that's getting blocked by pain, a mistake from the past, and that the way forward is to change my environment. How we unblock that and allow that energy to externalize itself by changing something in the environment. It's funny because my therapist sort of arrived at the same conclusion herself. You know what my therapist told me? So, anyway, how did you end up in Washington? As if to say, in a way, there's your fucking problem, bitch. That's a very good question, miss. I give you props for that. So it is my pleasure to announce this application. This application used to be available on Heroku. Now that Heroku free is no longer a thing, you can access this from a machine that's running in my living room. I created a cluster all on my own. Oh! So this is how it works. Then you get a random message. It's not very good. It's not very good. The code is kind of shitty, particularly the front-end code. This should be a front-end application. It shouldn't be a back-end application, but I mean, it can be a back-end application, but anyway. I saw that no one online had documented this or replicated it. So since the Heroku free tier died, or I hadn't been able to use this, so I decided, fuck, am I gonna run this on Lambda? What am I gonna do now? Like actually bite the bullet and run it on whatever bullshit AWS has? But the problem was that Lambda is not gonna work to run a website like this, to run a front end, because that's not the use case. Lambda is designed for APIs. They over-engineer everything, so you have to buy into different shit. The more shit that you buy into, the more of a captive customer you become. It becomes harder over time to separate yourself from the Amazon ecosystem, which it does have a lot of advantages. Like, they do sell at scale. Economies of scale. Have you ever heard that term? The reason why the Big Mac is so cheap is because McDonald's has a ridiculously massive operation that allows them to make billions of them, right? So Amazon has that. Amazon is at this point where it's ridiculously cheap for them to stand up more machines in the cloud, more servers in the cloud. I think AWS still has the free tier. We can use an entry-level version of all of these services, and it's gonna be incredibly fucking cheap or free for a whole ass year. That's kind of insane, right? But it's because, again, for them, compute is like nothing. It's like air. They literally manufacture their own boards right now. How insane is that? Their own motherboards, their own server racks. 1 million fee requests per month. I mean, that's bloody freaking good, right? But there's a catch. You're trying to migrate out of Dynamo? Oh my goodness. Oh, you're gonna have a really hard time trying to migrate out of S3. Again, for them it's nothing. They're adding petabytes upon petabytes upon petabytes of storage to S3 every month. I love curry. So that's why I figured, hey, let's try to run it on AWS Lambda, but it didn't work out for me. I thought that I had a freaking screenshot of it. I managed to run Sinatra on Lambda, which is pretty nice. I don't want to pay for a VPS. I don't want to pay for AWS Amplify, Lightsail, Elastic Beanstalk, or whatever thing they have. As much as I love Heroku, I don't want to pay for Heroku right now. And I figured, yeah, and I'm a stupid fucking idiot who likes to do things the hard way. So let's do things the hard way, right? And I ended up setting this. So this is sitting on my living room, and this is serving internet applications. I'm going to move my Homebridge server to this. So this runs quietly. It runs really cool. You don't need any special ventilation for this. You can get ventilation in your one, but you don't have to. I have a decent chunk of computing power there. I have 7 gigs of memory and I have 7 times 1.2 gigahertz, which is bloody freaking good, right? Right? I don't even know what module I got back then. Hold on. Don't see my fucking shame. Don't see my fucking dildos. All of the dildos that I've ordered over the years. To fuck myself in the fucking ass. So I order 8 gigs. No, 1 gigabyte RAM. So it's 8 gigs of RAM distributed. And it's 8 gigs of memory. So it's 8 times 7, which is pretty freaking good, right? So I ordered this. And then Turing Pi B1. And I have this, which so it's exactly the same build that I spoke about the other time. So it's a Turing Pi, which is really, really fun, really freaking good. So the Turing Pi sort of does the, it does the networking and all of the nitty-gritty, so you don't have to, right? So this is kind of like a little version of what you will see in a huge, in a real data center. And I found out incredibly freaking cool, right? Because you power this with 12 volts. 12 volts. And then you can check this guy out. You can run on this. You can run cubers. Actually, let me show you. Okay. Fuck. Tar XBF. Alfredo.pem, Alfredo.ppk. Jesus Christ. I suck, dude. Attacks. Tar. Okay, that's clean. To move K9s to scripts. Yeah, I have a move K9s open K9s. There we go. Okay, so I have this. So let me show you now. This is what I use to manage Kubernetes stuff. So a really wise engineer told me once, don't get used to the flashy stuff, to the C shell random bullshit, right? Because one day you're gonna have to use another computer, or you're gonna have to SSH into somewhere else, and you're not gonna have access to your usual fancy stuff. So don't depend on that. And I get it. He's right? So, but when I'm on my own, I will use the fancy stuff, right? So SCP pirate at Turing master home.cube.config copy config copy to this computer cube config. Why do I have that? Okay. Okay, there we go. So K9s. So now that I have kubeconfig, I can do this. And here's my cluster. So there's a oh Jesus Christ, I'm gonna deploy. So there's a demo deploy. So I'm gonna kill that. Yeah, okay. Sapto. Yeah, this is still up. Good. So this is how it looks, right? So there's Thank you. Southerly winds brings on his day. Southerly winds with bitch. Are you gonna? So how does this work? In fact, let's do a fucking architecture diagram. When you do an architecture diagram, it is more or less a free-form sketch, but you have to be nice and friendly and communicate what you're you communicate what your architecture is about, and but you have to be nice about it, right? So so we have like from the external internet, there's like client. So you're just gonna do client. The client's like whatever, right? So this goes through the cloud, right? So they're on a phone or whatever, and then they reach through the cloud. They reach my router. This router has an IP, right? It has an IP of, let's say, freaking 70.0.0.0, right? And this IP is dynamic. So what this means is that it will change over time unpredictably, because so this is from Comcast. This is a Comcast box, right? And Comcast decides what IP to assign to you. You have no control over that, and when to assign it to you. If you want a static IP, it's super expensive. There's a cost for that. It's super expensive, right? So there's this. So then instead of that, we do a little bit of a workaround by using dynamic DNS. There's companies that offer a service to to constantly update DNS for you. So on the public internet, some domain name responds to something, and you can run something on your actual machine. We're trying to like not use AWS here, right? All right. So anyway, so this is the router. It's connected to my Fresh Tomato router. .192.168.1.1. Alright, I'm gonna represent this by x.x.x.x because we don't know what it is and we can't predict it, and if we cannot predict it, we cannot reliably run a service on-prem. So this reaches Fresh Tomato, and from Fresh Tomato there's another machine, which is my cluster, a Kubernetes cluster. So this is gonna be like this. Kubernetes cluster. So let's align this to the bottom. Okay. So inside the cluster, okay, Fresh Tomato, it is connected by Ethernet. Let's make a note. Ethernet, it's an Ethernet interface. Okay, so this uses ingress, which is kind of a reverse proxy. Let's think. If you have implemented a reverse proxy, it is kind of like a reverse proxy. Traffic. So I am using traffic because I used a chart for this, which is pretty cool. Ansible K3s. There we go. So it is pretty cool because it's kind of like just plug and play, really. You just set up Raspberry Pis and it's plug and play. Recommended setup with Ansible playbook. All right, there we go. So, okay. So this is reaching the, and let's add another thing here for the fucking Turing Pi. So the Turing Pi is running a Kubernetes cluster. So a Kubernetes cluster has an ingress, goes through the ingress like this. Jesus. Okay. Goes to the ingress. And then, so this has 7 nodes. 7. I got 7 days to live my life and 7 ways to die. Just calling Turing master. And so in Kubernetes, the master node like dispatches tasks and handles the organization of the pods and everything below. Because so Kubernetes, well, let me show you now. So there's the master node, and then there's 6 workers. O2, worker 01, and O2, and so on and so forth. Yes, I know. I know, I'm sorry, I apologize for my fucking life. I know, Mexicans are not supposed to exist. So, okay. So there's the ingress. So the ingress reaches the node. How do I represent this? So basically, to the node, the capacity of all of the workers is just a single entity. It just sees one mass of horizontally scaled resources, right? That's the magic of Kubernetes, right? 6. Okay, so it's 6. So all of these run on the nodes. Master, and the master can communicate with either of this, right? I'm probably gonna have to polish that in a bit. I got 7 days to live my life and 7 ways to die. I wanna play a song. I wish that Twitch wasn't such an arc about songs. Fuck. So where something ends up, you don't control it. You don't control it. That's not for you to decide. That's for Kubernetes to decide, right? Kubernetes master. Okay, so in all of these, there's something. Let me represent this with another shape, I guess. back. Same backward. Same backward. Come on. So all of these all together form the Kubernetes stuff, right? So Kubernetes has nodes, and the nodes are the actual machines. So nodes contain pods, and for Kubernetes, a pod is a collection of containers, and everybody knows what containers are now. I may cover that later in another occasion, but so you have pods, and pods are pod one is I have the application pod, I have the traffic pod, so as you can see here, pods, if I access pods, there's other stuff that was set up for me by K3s, but there's 6 traffic nodes, traffic pods, and one of them has like several containers, 2 containers inside. So you can see, oh, okay, so there's LB port and LB port because the setup that I have handles 443 and 80, right? And there's this, and there's like other metric stuff, but I'm not very concerned about that right now, right? So, well, so pod exists so it's like this, right? So there's like the traffic pod. Oh, fuck. Traffic. And there's like little containers, and I could even go and get a little whale for Docker and place it there because it's Docker, es que bonito. So I could get it there. Okay. Port 80. So this is the port 80 container. Fuck. There's the port 443 container. Let's make it a little bit. This is sucking. Not the best diagram I've ever made. And I've made some really shitty diagrams, believe me. Alright. Because this, ideally, if I feed it, let's encrypt cert, so it will work with let's encrypt, which is pretty cool. And in fact, I should do it. So there's, because fuck you, you have to encrypt everything. So there's this, and so I have 6 of this, right? No, I have 7 of this actually. 1, 2, 3, 4, 5, 6, 7. So it's 7 of them, right? It's because there's traffic pod. Fuck, how can I do this? And the cool thing is that Kubernetes has ways to set up all of this, so it is really elegant, and and it responds to, so it becomes hardened, so it responds to if something goes down, so spin something else to keep it up. So you can also scale horizontally at will. You can also, so a pod is an abstraction separate from the workers. You don't control where something ends But that's good because that way Kubernetes handles all of that for you, so you don't have to, right? 1, 2, 3, 4, 5, 6, 7. Okay, so there's the traffic pods. There's the application pod. Right? So Kubernetes is only concerned with these abstractions. And so, quote unquote, so that's the win, right? Like you don't have to negotiate where everything ends up, right? So this is made by the really smart people at Google, people smarter than I am, right? So the ingress is part of the cluster. Let's move all of these guys. You know what I'm gonna do? You know what I'm gonna do? I'm gonna do this. I'm gonna do this. Jesus Christ. I want to show that this has. Oh, fuck. Okay. So drink by. Okay. Jesus. So there's the ETH0 of the Turing Pi on Ethernet, on an Ethernet interface. We have this, right? So here we have 7 machines, right? All of these are the Kubernetes cluster. Okay. Shit. I'm gonna remove this caption. I'm gonna add it back again here. Okay. During PI. During Pi. Bitches asking into know what the coke at. Living like a rock star, living like a rock star, living like a rock star. Alright, so let's say that, let's, yeah, kind of shoddy, but whatever, right? Freak. Okay. Well, okay, Jesus. So there's that. So here, after you hit the application path, so the application pod in this case has 2 things. Oh no! It has a container for Sinatra. It's serving on port 567. So again, so this means that, for example, this is a separate computer. This is a separate computer. And it's like many sets of the same separate computers, which is kind of insane, right? But that's another one, like that's the win on the Kubernetes side, like theoretically, right? So there's this. And so, and also here I have a no IP container. So this is just running request to update IP because so there's a problem which I'm gonna show again in a bit. So after there's an ingress here, right? So this goes to something that's called a load balancer. And the load balancer is going to pick one of these 6, right? It's going to run Rowan. Looks kind of cool, but it's kind of shoddy at the same time. Oh, fuck. So there's that. So the ingress communicates with this. And one of these hits the respective service, right? So this is on port 80, load balancer, the ingress. So it has port 82. Okay, so when you get a request here, okay. So what happens is that this can, okay, so load balancer hits, let's focus on this, I guess. And then there's that, right? So this will hit the application pod, which I guess I should scale up. So the traffic nodes are for each one of the nodes. The traffic pods are for each one of the nodes, right? So in this, so what's going to happen is this, right? This is a really shitty diagram, and I'm sorry. Is it too late now to say sorry? I'm just gonna add a single line. So the application pod is exposed with a service. Hosts, ingresses, service. Notice how there's a load balancer service from traffic and there's a Fortune's service. So what happens is that each one of these has an internal. So inside of here, there's a virtual network, and you don't control it, and you cannot see exactly how that is determined, and it doesn't really matter, right? It doesn't really matter anyway. So there's no such thing as, oh, let me hit this application pod, because this application pod is going to have its internal IP address change at some point. So this needs to go through a service. So, and each application pod or each thing that you mount on this should should have its own service fronting it, right? So this is gonna reach the it's a service on port 80, and the service hits port 4567. So this does something, and it returns a response to the client, right? So I'm gonna sort of leave it like that. So meanwhile, so this is the no IP container. So meanwhile, this is talking to no IP on the cloud. What a shitty diagram. Kusugaki. So this is requesting to this. Alright. Requesting to. So no IP.com and whatever services they have, right? So no IP.com, what this does is that so it updates DNS, right? So this send IP is XXXX, right? It's not gonna report application path IP AAAA or whatever there, because you're not concerned about that application pod. You want to not have to worry about that application path. Like you want to work with the abstractions, right? So this communicates on the internet to noip.com, and the NoIP says, oh, okay, so I got a request for that, so I'm going to update DNS. So let's represent it with this, right? Let's represent it with this, with DNS. So this is gonna tell things. Hey, you know what? So, oh fuck. Shit. I already used this. I already used that the other time. $95 a fucking year. Oh, fucking ever. Yeah, let's try that. Oh fuck! What a terrible approach to that. Okay, anyway. So this is update. So this is like, I am certain that this guy, so he's cool. He has an account with me, and I vouch that SMB dxfortunes.sap2.org maps to XXXX, right? So then, so now this happens. So the client with their phone or whatever, so it makes a DNS request to this, and it says, oh yeah, sure. So what you should be using here is XXXX. So this is where the service is, and then you can reach it. Oh, thank you. And so over time, if that changes, it's not to worry, right? Because fuck. One, so 2. So that replies that, and then okay, so now the client request XXXX on port 80, and this has a port forwarding Oh no, so this is a port forward. $80 and 443, which are port forwarded to something, to the and 92 1.168.1. Something. Support forward. Port forward. 192.168.1.x. Pretty certain I got this wrong, how I'm representing the 3 or 4. Put forward to that. Then there's a load balancer, right? Load balancer, so takes a certain request on a certain port, is forwarded to service on port 80. Forward to service, and then the service, okay, and the service hits the application path. Are pods exposed? So this is a pod, and my pod contains two containers. Okay. No, so pods don't have that abstraction. So after that, it's like Sinatra. So this hits the Sinatra pod. So this does everything it needs to do. Add a note. I'm trying to suck less, okay? I do 6 compute fortune. So it's gonna compute a fortune. How? Well, on the container itself, right? Okay, so this. Let's do this application pod. So on the container itself, so here there's a database. There's SQLite, because I don't want to maintain a database server for this, because it's really simple data and it's just, you know, just static. So computes the fortune. So this connects to that, retrieves something, and then computes the fortune. 7. Respond fortune. So then this goes all the way back to that. And again, all of these exist distributedly things. Some BDX fortunes, application pod, Sinatra, and the no IP container, so that just runs every so often. Just updates. Oh yeah, you know. So I discover that we have this IP, and so that happens. Oh, fuck. It's kind of shitty. Export. I wonder what can I do better. Maybe later. Later, potatoes. So I can probably do that. I'm gonna correct this, but this is basically how it works. So you want to see your fortune. So you hit a DNS server, you get a response. This is my IP. This is my house. Where's the house? Where's the house? Oh, I'm not gonna use one of those. So I'm just gonna send back behind everything, because all of this is in the house. The call is coming from inside the house. So my house. So this is my house. This is my house, bitch. This is my house. My house. So that way, effectively, I'm serving stuff from the house. From my house, right? Where did this fucking go? Client. So somebody from outside reaches DNS. DNS gives it an IP. Then 1, 2, 3. Request on port 80. So this has this breach. Port forward. And so this knows what to do. It port forwards to the ingress. The ingress hits the load balancer. Load balancer hits the traffic pod. Traffic pod hits the service, the application service. The application service hits the container, and then it returns a result. How's it going, fam? I'm making a diagram. I'm trying to see what's up. I'm trying to like document something that I did. Okay. So yeah, so this is from so I set up Kubernetes. So this is kind of how it goes. Oh no. Dios mío. So it is kind of how it goes. So this hits the Turing Pi. Turing Pi is running 7 Raspberry Pis. So actually I have a change here, so it goes through the master node. And then the master node goes to the ingress. Let's make it like this. No, because if I do that, it sort of looks as if the ingress is the cluster itself. Load balancer, the service. Seven. Of course, we ended with 8. Spawn 14 back to the client. Oh, kind of shitty and kind of like not completely true, but you know. Okay. 7 compute 14. 8 respond 14. Oh my goodness, not the best diagram I've ever made, but I guess, you know, somewhat there. So let's export it again. Okay. What's important to understand is that ingresses allow traffic from outside the cluster, right? Ingresses are like reverse proxies. Okay, show you. And let's just say that, you know, okay, so just yeah, I know I'm an idiot. So, okay, so this is connected to every one of these. So these are task runners and this is a master. And so ingress, load balancer. Not perfect, but I guess. So again, I'm trying to suck less, okay? Give me a fucking break. So let's say that we add this, we add this. I'm gonna fuck off, I think. In fact, I should stop doing this. It's like, you know, what's the point, right? And we get this, which is really nice, right? So it's good for the soul to host stuff locally. Sometimes the hard way is the best way. So yeah, so I think that's it. What else do I do with my fucking life now? Other than Architecting Kubernetes. Oh, and it gets even worse when you have to install like custom resources. So you can install different definitions of domain models inside Kubernetes and consume it. Like all of that is just bullshit. And then third parties start doing that. It's just fucking bullshit. Oh, and there's this obscure given to their domain model that you never knew about that they decided on arbitrarily because the CMCF is wiser than you, and they are, by the way. But oh, how did I know that a certificate provider had to be a certificate manager had to be? How did I? Like again, that's what I mentioned. By it's too obscure. It's too obscure sometimes. What else is the problem with Kubernetes? kubectl is a terrible tool. It works. It's ugly. K9s is K9s made me actually be able to stomach Kubernetes. kubectl is just terrible. There's a lot of obscurity, contexts, and the namespaces, and to a newbie, a lot of those things are completely obscure. I'm tired. See you later.